Okay, one thing we want to be able to do is to use a grid and be more specific about our congruency. And in computer systems, like using Inkscape and whatnot, um, we typically use a grid to be more precise. So we want to be able to map if two shapes are congruent in a grid space. And we do it the same way we do with the patty paper. It's just not as freehand or using compass and ruler type tools. But we use the math. So we're going to use specific instructions. So there's different ways that I can use isometries to get this shape mapped onto this shape. I'll go through a couple different ways that we could do it. The one that kind of stands out to me as my first way to do it, and you can be thinking about other ways that might be possible. But I would think that if I flip this thing over, if I mirrored it across the y-axis and then shifted it down, that would be a good way to do it. So when you mirror something, you go the exact same distance away from that mirror line on this side as you would on this side. So it's just like when you look into the mirror, you see your reflection, and your apparent reflection would be the same distance away from the mirror as you are yourself. So point C is going to reflect across this line and go the same distance over here, and we would call that C prime. And then B, it looks like it's 3 away from the mirror line, so it would go 3 away right over here. So we call that B prime. And then A, going straight across, and the line that we're looking at of reflection is perpendicular to that surface. So this is 5 away from that line in a perpendicular direction. And actually that is the shortest distance. You know, you can take a compass and prove it to yourself, but that is the shortest distance to that mirror line. So let's see how that's a little bit further away. This is a little further away, and the closest I can get is right when the distance is perpendicular. That's the closest I can get. If I go any shorter, then I'm not touching the line, see? So the distance from A to the y-axis would be 5, so I go 5 in this direction, and we call that C prime, or A prime. Okay, so we made a new triangle, and this triangle, because we did an isometry of reflection, it is a congruent triangle to the original. And now I can do another isometry to map this one on top of it, and this would be just a simple translation or a move. And I could just move this point 1, 2, 3, 4, 5, 6 spaces down to make it C double prime. And then move this one. I have to move the same amount, right? So if this is 6, this should also be 6. 1, 2, 3, 4, 5, 6. If I didn't end up on point Q, I would immediately be able to say these two shapes are not congruent, but so far we're okay, so B double prime. And finally, A needs to go also 6. 1, 2, 3, 4, 5, 6. And it maps directly on top of P. So that now I know that ABC is congruent to PQR. Okay. Can I do it another way? So let's just try the same thing, but this time instead how about I translate first and then reflect. So if I translate, let's see, I want to be the same distance down, so I think this is also 6, right? So 5, 6. 3 and 3 makes 6. 3 and 3 makes 6. So that translated first. And then I reflected across, so this is 1 and 1, so works. This one is 5 and 5, works, and 3 and 3. So This time I used a different order of isometries. Before I reflected and translated. Now I translated and reflected, and it still worked. Okay, let's try one more. So what if let's get crazy with it. How about if I just reflect, instead of across the y-axis, I'm going to reflect just across this vertical line at x equals -1. So x equals -1 is this line right here. If I reflect, C itself goes right on top of it. And if I reflect B, now it's 2 away from that line, so it would be 2 over here. And A is 4 away from that line, so I would go 4 over here. And my new triangle. So C itself was touching the mirror, and that's okay. You can even have a mirror that's going through the whole shape. And so imagine if the line was x equals -2, then C would actually reflect over here, and your triangle would be something like that. Okay, and then now I want to translate this triangle over to here. So how do I translate it? Well, instead of going in a straight vertical or horizontal direction, now I have to kind of go at an angle. So I can just remember that this is a rigid transformation, so everything is going to move the same distance. So the way we can do that is thinking about the slope. So I'm going to move this point down 6 and over 2. So down 6 and over 2 would be that translation. So this one also, so let's actually, I could use maybe some patty paper. So it's going down 6 and over 2. So this same little L shape that I made, going down 6 and over 2, should be the same for this one, and you can see that it is, and the same for that one, and you can see that it is. So I'm going down 6 over 2. This one goes down 6. So 1 and 5 makes 6 over 2. And this one goes down 6, so down 2 and then 4 more, and over 2. So you can see those L shapes that it translated, and each point translated by the same amount. Okay, that's it. Using the coordinate grid, you can use reflections, translations, and rotations. We could do a rotation too. But with this type of shape, it seems that it would be more steps than would be necessary.